Good morning everyone, this is Chomoji. So I woke up this morning and decided to give you this free class. Yeah, because a lot of people from my last video kept on arguing about the last method I used in solving, and the method I used was the U-substitution method. I used the U-substitution method to solve. Let me tell you the advantage of the U-substitution method. The U-substitution method is used to break down functions like this. You can see this is a function x raised to the power 3. This is another function exponential x raised to the power 4. You know where functions are coming from. Functions are definitely coming from a graph. When you have the x-axis, you have the y-axis, then any point on the graph where they both meet is the function. You can call this f of x1. If they meet here, you can call it f of x2. Guys, I'm starting from the origin because a lot of people don't understand where this stuff is coming from. No need arguing. If you know you are an authority in something, you don't need to argue. If I've argued with you before, I withdraw my argument. So now you come, because it's true that I don't have patience with people like that. I don't have patience. But again, so you see, f of x1 here could be x is equal to 2 from 1. Then you take the second function, f of x2 could be what? Exponential x to the power 4. I'm being very careful because that was just a sample video showing you one of my classes with my students. So even though there was a mistake there, does not mean that I don't know what I'm doing. I saw a lot of people saying she doesn't know what she's doing. Very annoying. This is Chomoji BBT. Now let's use U-substitution method on this. Using U-substitution method on this solution. Using U-substitution method. U-substitution method. Right? We want to use U-substitution method on this. So you have integral of x to the power 2 exponential x to the power 4 dx. So I'll have to clean here because I want to share the board. So I'm going to share the board. Remember that this is the question I'm solving. Sorry, this will be very long because I'm going to solve all these questions above. So if we use this, I'm going to take this side of the function. I want to take this side of the function. So if I take this side, I have to introduce something by turning this whole thing from the s to the u. Why are we doing that? We want to subsidize this. We want to reduce it in a way where we can now integrate. We want to break it down. You cannot expand. So many people that use expansion, you cannot expand this. If you expand this using your normal method, I told you guys there's a law to mathematics, there's a law to calculus. I told you guys several times, there's a law to calculus. Sorry, this video is going to be long. I'm trying to explain something. Do you want to expand integral of x to the power 3 exponential x to the power 4 dx? Can you use your normal expansion method on this? So now using your substitution method, we are taking this whole side. So we would call this integral of x to the power 3 exponential u. The whole of this is u dx, where u equal to what? X to the power 4. Now we want to find du dx because we want to substitute to remove this and then break this thing down to get rid of exponential 3. Why are we doing it? We have two functions working together. Two functions are attached. We cannot solve them linearly according to your method because your method, yes, all methods should give the same answer, yes, but there are exceptions. That particular question was an exception. When I solved this last question, you will find out that that particular method was an exception. I took the same, I had to formulate the same question. The only difference is that there's a power of 4 here. I just want to prove to you that that mathematical function and question was an exception. You get? So if you want to be open-minded, you follow. But if you want to still be narrow-minded, this is me this early morning trying to calm down because I was really pissed to explain to you. Now just listen. For those people that want to learn calculus, listen, okay? Now we've gotten this. Now the u dx of this, okay, the u dx of this is 4x 3. Now once you make the x subject to formula, you say the x 4 x to the power 3 equal to du. Now the x becomes du over 4x to the power 3, equation 2. We've gotten what we need. So taking it back to this equation, we have integral of x to the power 3 exponential u. Remember, we substitute u. Where there is the x, we substitute du over 4x to the power 3. Notice something is going on here. Notice that we can easily just cancel and make this linear. Why do we use U-substitution? It's to break functions down. U-substitutions are used to break functions down. And when we break functions down, we make it linear so that we can now apply linear integration. That's what I'm trying to tell you. That particular question you saw was an exception. You can use the expansion method. You don't even need to if you don't want to use U-substitution. But this is where I added 4 to it, a power of 4, to show you where you can now use U-substitution in that particular question if you don't want to use linear. And also to prove to you that linear expansion of integral will not work in all functions. Now, we've done this. You can see that clearly this can cancel this. You can see it clearly that this can cancel this. So if this is cancelling this, what do we have? 1 over 4. 1 over 4 has to go out. Then the integral of exponential u. Then everything here is now du. So let's work the operation using the integral of this part. So if you integrate this, therefore you have 1 over 4. You put a parenthesis just so you understand it. Then integral of exponential u du. You close the bracket. So using this integral operator on this, you have 1 over 4. You still leave your parenthesis just to understand. You know this is equal to this exponential u plus c. You see? So your final answer becomes 1 over 4. You substitute u is equal to x raised to the power 4 exponential x raised to the power 4 plus c. This is the final answer. Guys, you have seen that we reduced this function to something that looks as simple as this, and we got this. So now, because I'm going to break down, this class is going to be so long.